So let's begin with a review of the sampling distribution of the sample proportion. Suppose that 40% of residents in a city are Hispanic. A random sample of 500 residents is obtained. A. Fully describe the sampling distribution of the sample proportion. So the mean is mu sub p hat, which is the value of the rate in the population P, which in this case represents the 40%, which has a decimal of 0.4 for Hispanic. Now the standard deviation, or the standard error of the proportion, is sigma sub p hat, which is that square root calculation. Square root p times 1 minus p over n, which is square root of 0.4 times 1 minus 0.4, or 0.6, divided by 500, which turns out to be 0.021909 when rounded. What about the shape? Okay, can we treat it like a normal distribution? A random sample of residents was taken, and the responses were yes for Hispanic or no for non-Hispanic. So it's categorical data. And then n times p is 500 times 0.4, which is 200, and that's more than 10. And n times 1 minus p, or n times q, would be 500 times 0.6, which is 300. That also is more than 10. So what that allows us to do is say that the normal conditions have been met, so we can treat the sampling distribution like a normal curve where the mean is 0.40 and the standard deviation is 0.021909. B. What is the probability that 215 or more of the sample will be Hispanic? So we start by calculating the sample proportion p hat, which equals 215 divided by 500 equals 0.43. Then z equals the sample proportion p hat minus p divided by the standard error, the square root of p times 1 minus p over n. So we get 0.43 minus 0.40, then divide by 0.021909, so the z-score is 1.37. Now, if you sketch the curve out, what you're talking about is sort of this normal curve, mean of 0.4, we want 0.43 or more. So the 1.37 for the z-score is equivalent to the sample proportion of 0.43. Okay, so the probability of getting more than 0.43 would be not the area to the left, which when you look up the z-score of 1.37 is 0.9147, but rather the area to the right. So 1 minus that area is 0.0853. So we would summarize by saying the probability that 215 or more of the sample will be Hispanic is 0.0853, and that's this area in the right tail of the curve. Next, what if the population proportion is unknown? So instead of being told, we know the rate is 40% for Hispanics. How can we confidently estimate the value of the unknown parameter? Let's begin by just asking what percent of sample proportion values, p hat values, are going to lie between p minus 1.96 sigma sub p hat and p plus 1.96 sigma sub p hat. Well, in terms of z-scores, negative 1.96 and positive 1.96, because your 1.96 standard deviations below and above the mean, okay, what would those be as z-scores? Okay, the negative 1.96 gives you an area of 0.0250 to the left. The positive 1.96 z-score gives an area of 0.9750 to the left. So the difference would be 0.95 or 95%. So 95% of sample proportions, p hat values, would lie between 3.57 or 0.357 and 0.443, which is the 0.4 minus and plus the standard error. Notice this implies for these particular sample proportions, these 95%, that the distance from P, 0.4, to P hat, like where this orange value is no more than that 1.96 times sigma sub P hat value. So if we have the sample proportion, P hat, there's going to be a 95% chance that if we just add this distance, that 1.96 sigma sub P hat, that blue length, okay, if we add that, we're going to capture the value of the proportion if we start at P hat and add and subtract this blue length. So for this orange dot, if I subtract, I'm going to be down here somewhere, and if I add, I'm going to be up here somewhere. And notice the endpoints from this lower limit to this upper limit do capture the value of the population parameter. Now what we're going to talk about are different values we could use. Okay, in this particular case, we looked at 95% being the value trapped in the middle of the graph. Okay, we can actually do this for several different values. Okay, and we are going to call these the level of confidence. So for 90% confidence, we're going to use a z-score of 1.645. For 95% confidence, we used the 1.96. For 96% confidence, we'll use 2.054. For 98% confidence, the z-score will be 2.326. And for 99% confidence, we will use 2.576. Now these are the only 5 levels that we're going to talk about. Okay, so this table right here, you should probably just write down on your table Z, okay, in the margin somewhere so that you have it. Now the formula we're going to use is, say, start at the sample proportion P hat, add and subtract the z-score, which is going to depend on the level of confidence, and then we're going to take the square root of P hat times 1 minus P hat over n. Although we would like to use the true sigma sub P hat, which has the value of P in it, that's the unknown. So what we do is estimate it the best that we can by using the sample proportion in place. So this is an approximate confidence interval for the population proportion P. So let's look at one application. Suppose we take a random sample of 500 residents, so our sample size is 500, and find that 185 are Hispanic. Estimate the proportion of all residents who are Hispanic, so estimate P using 95% confidence. So in these exercises, you want to begin by defining the parameter you're estimating. So the parameter is the proportion of all residents who are Hispanic. Next, you do your calculations. So the sample proportion is the number who are Hispanic over the number in the sample. So 185 over 500, which is 0.37. Now if you're doing these calculations in the homework or just practicing, make sure that you keep the number of digits indicated. Sometimes in the homework it'll say round to 4 decimal places. If I'm doing it, typically I'm going to keep 6 unless it turns out to be exactly the number. In this case, it turns out to be exactly 0.37, so the next 4 digits would all be zeros, so I don't write those. Now plug the values into the formula. So 0.37, one time I'm going to come through and subtract, and that'll give me the smaller number or the lower limit. Then I'm going to come through and add, and that'll give me the upper limit or the larger number. The z-score is 1.960. And again, that comes from the fact that I want 95% confidence, and for 95% confidence, the z-score is 1.96. Then, underneath the square root, we use the 0.37 times 1 minus 0.37, which is 0.63, divided by 500. When you do those calculations, when you do the subtraction, you should get 0.328 when you round off to 3 digits after the decimal point. And when you do the addition, you should get 0.412. Finally, we want to summarize our information. Now the summary is going to have basically three components. You want to tell the level of confidence that you're making the statement at. So how certain, how confident are you in the procedure? Okay, and that'll go back to the level of confidence you used in the exercise. Tell what it is you're estimating. Okay, so we're going to be estimating the proportion of all residents who are Hispanic. And then give the bounds, the lower limit and upper limit, which you believe capture the value of the parameter. So this would look something like, I am 95% confident that, what is the parameter? The proportion of all residents who are Hispanic, and then what are the bounds on it? Is going to be between 0.328 and 0.412. Or you can convert these to percentages and round off usually to the tenths digit. So I might say I am 95% confident, okay, that 32.8% to 41.2% of all residents are Hispanic. So that is the way that we are going to do estimation for this material. So this is going to be the formula that you use, and you want to make sure that you have this table with all the z-scores based on level of confidence handy when you're working these exercises.